Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
You've built multi-region architecture, Aurora, DynamoDB, EKS, networking, observability, DNS, failover. It works perfectly in staging. Now comes the moment of truth. Actually failing over during a real outage at 2 a.m. without making things worse. Here's what typically happens. Primary region fails. You wake up to pages. Half asleep, you start executing failover. Skip a step in the runbook. Promote Aurora but forget to update DNS. Or update DNS but Aurora promotion fails. Or both work, but secondary region doesn't have enough capacity. Outage extends from 20 minutes to 4 hours. Revenue loss multiplies. Post-mortem reveals basic mistakes. Today you're learning disaster recovery procedures that actually work in production, not the DR plan that sits in a Confluence document nobody reads. The actual runbooks engineers execute successfully at 2 a.m. under pressure. By the end of this lesson, you'll understand how to test failover without affecting production. The step-by-step Aurora promotion procedure with validation at each stage. EKS. Traffic shifting with rollback safety. Rollback procedures when failover makes things worse. And chaos engineering to validate your DR actually works before you need it. Let's start with testing DR without causing downtime, because your first failover shouldn't be during a real incident. Most teams build multi-region, deploy it, never test it. Then primary region fails. They attempt failover for the first time ever. Discover health checks are misconfigured. Secondary Aurora doesn't have write permissions configured. Route 53 failover policy has a typo. The DR solution doesn't actually work. Testing strategy 1. Weighted routing for traffic sampling. Before attempting full failover, use Route 53 weighted routing to send 1% of traffic to secondary region. Episode 8's routing policies. Monitor error rates, latency, database write success. If secondary handles 1% perfectly, gradually increase to 5%, then 10%. If errors spike, you found issues before full failover. Real example. E-commerce site tested secondary region with 1% traffic. Discovered DynamoDB global tables hadn't fully replicated yet. Some items missing in secondary region. Users in that 1% saw product not found errors. Fixed replication issue before attempting failover. This test prevented what would have been a disastrous full cutover. Testing strategy 2. Game day exercises and staging. Schedule quarterly DR drills. Simulate primary region failure by blocking traffic at network level. Execute full failover procedure in staging environment with production-like data. Time how long it takes. Document what breaks. Update runbooks based on findings. Netflix does game day exercises monthly. They randomly terminate instances, kill services, simulate AZ failures, simulate region failures. Engineers practice recovery procedures regularly. When real failures happen, muscle memory kicks in. No panic, just execution. Testing strategy 3. AWS Fault Injection Simulator. Inject faults into production safely. Throttle Aurora to simulate performance degradation. Packet loss on cross-region connections. Terminate random EKS pods. Observe how systems handle failures. Validate monitoring alerts fire correctly. Confirm autoscaling responds appropriately. Start small. 1 pod termination. Then multiple pods. Then simulate database slow queries. Then network partition between regions. Gradually increase blast radius as confidence builds. This surfaces issues in controlled manner before real failures happen. Now Aurora failover procedure step by step with validation gates. Step 1. Verify replication lag. Before promoting secondary, check Aurora replication lag is under 5 seconds. Episode 3 explained why this matters. Lag above 10 seconds means promoting will lose recent writes beyond RPO. CloudWatch metric approximate replication lag shows this. If lag is 30 seconds, wait for it to drop or accept data loss. Step 2. Stop writes to primary. Put application in read-only mode or route writes to a maintenance page. This prevents new writes during promotion that would be lost. Drain in-flight transactions typically takes 10 to 20 seconds. Application health endpoint returns degraded status. Route 53 stops sending new traffic. Step 3. Promote secondary to primary. AWS console or CLI command, AWS RDS promote read replica . This takes 60 to 90 seconds. Aurora reconfigures secondary from read replica to standalone read-write instance. During this time, no writes are possible to either region. This is the service interruption window. Step 4. Verify promotion succeeded. Check Aurora instance status shows available. Attempt test write to verify write capability. Don't enable application writes yet. Verify replication if you have additional read replicas. Step 5. Update Route 53 to point to new primary. If using failover routing with health checks, this happens automatically when old primary health check fails. If manual, update a record to new primary endpoint. Wait 60 seconds for DNS propagation based on TTL from Episode 8. Step 6. Enable application writes. Change application from read-only mode to full operation. Monitor error rates carefully. Slowly ramp up write traffic to avoid overwhelming newly promoted instance. Watch for replication lag if you have other regions. Step 7. Validate end-to-end. Execute test transactions. User sign-up, checkout flow, database writes. Confirm everything works. Check observability dashboards from Episode 7 showing healthy state. Total time for planned failover, 2 to 5 minutes. 90 seconds Aurora promotion, 60 seconds DNS propagation, remaining time for validation and traffic ramp. Unplanned failover is messier. Primary region completely offline. Can't gracefully drain traffic. Can't verify replication lag because primary is unreachable. Must accept potential data loss within RPO. Unplanned procedure. Immediately promote secondary Aurora. Don't wait to check lag. Primary is dead. You have no choice. Promotion takes 90 seconds. Update Route 53 health checks if needed, or they may auto failover. Enable application writes immediately. Scale secondary EKS compute from 25% to 100% capacity. This takes 2 to 3 minutes for auto-scaling. Monitor observability dashboards to verify secondary is handling full load. Accept that some recent writes may be lost. Inform business stakeholders. Real unplanned scenario, US East 1 complete region failure at 6 a.m. Primary Aurora unreachable. Team promoted US West 2 Aurora immediately. Updated Route 53 manually because health checks failed slowly. Scaled EKS from 15 pods to 60 pods. Total recovery time, 4 minutes. Data loss, 8 seconds of writes before failure. Business accepted this was within RPO. Users experienced 4-minute outage instead of hours. EKS traffic shifting procedure is separate from database failover. For hot-warm with DNS failover, Route 53 health checks mark primary unhealthy. Traffic automatically routes to secondary via failover policy. EKS pods in secondary region receive traffic. Auto-scaling triggers to handle increased load. Monitor pod health and scaling events. Typically takes 2 to 3 minutes for full traffic shift. 4. Hot with service mesh from Episode 11. Envoy circuit breakers detect primary region failures. Automatically route to secondary region at request level. No DNS wait, sub-second traffic shift. But you still need to scale secondary compute to handle full load. Validation during EKS failover. Check pod health in secondary cluster. Verify services are responding. Test application endpoints. Monitor error rates for spikes indicating issues. If error rates above 5%, investigate before completing failover. Rollback procedure when failover goes wrong is critical. Scenario: you promote Aurora to secondary region. Discover critical application bug only present in secondary. Error rates spike to 30%. Users flooding support. Continuing on secondary is worse than original outage. Rollback steps. Demote new primary back to replica role if possible, or promote original primary again if it's healthy. Update Route 53 to point back to original region. Re-enable rights to original region. This can take another 2 to 5 minutes. Meanwhile, users experience errors. Prevention. Always test with weighted routing first before full cutover. 1%, 5%, 10% traffic to secondary. Catch application bugs before going all in. Rollback decision tree. If secondary has higher error rate but primary is completely offline, stay on secondary and fix bugs. If primary is recoverable and secondary errors are severe, roll back. If both regions have issues, choose the one with fewer errors and fix both. Real rollback example. Financial services company failed over to secondary during primary database performance issues. Discovered secondary region's network configuration was wrong, causing intermittent timeouts. Error rate was 15%. Primary was slow but functional at 2% errors. Rolled back to primary, accepted slow performance while fixing network config in secondary. Later failed over successfully after fix. Chaos engineering to validate DR actually works. Chaos monkey principle. Inject random failures continuously. Don't wait for real failures to discover your DR doesn't work. Proactively break things in controlled manner to validate resilience. For multi-region, randomly terminate primary Aurora replica. Force failover to secondary. Validate promotion works. Do this monthly. Eventually, it becomes routine. Engineers aren't surprised when real failures happen. Chaos Kong for regional failures. Simulate entire region going offline. Block all traffic from primary region. Force full failover to secondary. Run through complete procedure. Time it. Identify bottlenecks. Update runbooks. Do this quarterly. Netflix runs Chaos Kong exercises where they take down entire AWS regions intentionally. Engineers practice full regional failover. They discovered issues with cross-region service dependencies, DNS propagation delays, insufficient capacity in secondary regions. Fixed these issues before real regional failures occurred. Litmus test for DR readiness. Can you execute full regional failover in under 10 minutes without incident commander having a panic attack? If yes, your DR works. If no, more practice needed. Common DR mistakes that extend outages. Mistake 1. No documented runbooks. Team has DR architecture, but no written procedures. During outage, engineers Googling how to promote Aurora read replica, making it up as they go. Mistakes multiply. Fix. Write detailed runbooks with screenshots, exact commands, validation steps. Store in accessible location. Practice them quarterly. Mistake 2. Runbooks outdated. Wrote runbooks 2 years ago. Infrastructure changed. Runbooks reference old DNS names, deleted resources, incorrect commands. Following them breaks things further. Fix. Update runbooks after every infrastructure change. Test them quarterly to validate accuracy. Mistake 3. Insufficient practice. Built DR. Tested once during initial setup. Never again. Real failure happens year later. Nobody remembers how to execute. New engineers never practiced. Fix. Quarterly game day exercises. All engineers participate. No exceptions. Mistake 4. No rollback plan. Team has failover procedure, no rollback procedure. Failover goes wrong, they panic because they don't know how to undo it. Fix. Document rollback steps alongside failover steps. Test rollback procedures. Mistake 5. Insufficient secondary capacity. Secondary region runs at 10% capacity to save costs. During failover, autoscaling should bring it to 100%. But hitting EC2 instance limits takes 10 minutes instead of 2. Fix from episode 9, run secondary at 25 to 30% capacity. Request limit increases proactively. Mistake 6, no monitoring during failover. Execute procedures blind without checking if they worked. Promote Aurora but don't verify it's writable. Update DNS but don't confirm propagation. Assume success, actually failed. Fix. Validation step after every action. Use observability from episode 7 to verify each step. Before we wrap up, pause and answer these questions. Question 1. Why should you test failover with 1% weighted routing before attempting full cutover? Question 2. During Aurora promotion, how do you prevent data loss from in-flight writes? Question 3. If failover to secondary causes worse errors than original primary issue, what do you do? Take a moment. Answers. Question 1. To discover configuration issues and application bugs without affecting all users. 1% traffic to secondary validates it works. If errors spike in that 1%, fix issues before exposing all users. This prevents turning a partial outage into total outage. Question 2. Stop writes to primary before promotion. Put application in read-only mode. Drain in-flight transactions, typically 10 to 20 seconds. Then promote. This ensures no writes are in progress that would be lost during the 60 to 90 second promotion window. Question 3. Rollback. If secondary errors are worse than primary issues, demote secondary and promote original primary again. Update DNS back. Accept the original issue was better than the new issues. Meanwhile, fix secondary issues, then attempt failover again later. Let's recap what we covered. First, test DR before you need it. Weighted routing with 1% traffic. Gameday exercises quarterly. Chaos engineering with fault injection. Your first failover shouldn't be during a real incident. Second, Aurora failover procedure has 7 steps with validation gates. Check lag, stop writes, promote, verify, update DNS, enable writes, validate end-to-end. Takes 2 to 5 minutes for a planned failover. Third, unplanned failover. When the primary region is completely offline, means promoting immediately without checking lag. You accept potential data loss within your RPO. The focus is on speed over perfection. Fourth, rollback procedures are mandatory. Document them alongside your failover procedures. Test them. Have decision criteria for when to roll back versus push forward. Fifth, chaos engineering validates that your DR actually works. Monthly chaos monkey exercises. Quarterly chaos Kong regional failures. Practice until it's muscle memory. Sixth, common mistakes. No runbooks. Outdated runbooks. Insufficient practice. No rollback plan. Insufficient secondary capacity. No monitoring during failover. All of these are preventable with discipline. Remember episode 2's hot warm 5-minute RTO? That's 1 minute for Aurora promotion, 90 seconds for health check detection, 60 seconds for DNS propagation, with the remaining time for validation. Episode 7's observability shows you what's happening during the failover. Episode 8's Route 53 health checks trigger the automatic failover. All the pieces come together during the actual DR execution. We'll revisit DR costs in the episode 9 context. How much does a DR test cost? How do you minimize it? And in episode 15 on anti-patterns, we'll see what happens when teams skip DR testing. The disasters that could have been prevented. Next time, financial services compliance, SEC, SCI, MiFi D2, crypto regulations. Everything we've covered assumes you can architect for your business needs. But regulated industries don't have that luxury. Compliance mandates specific RTO, RPO, data residency, and audit logging. You'll learn SEC regulation SCI requirements for stock exchanges and how they drive multi-region architecture. MiFi D2 data residency for EU financial firms. Crypto regulations like NY BitLicense and the EU's MiCA. You'll see how compliance becomes the primary architecture driver, overriding cost considerations. and audit logging that satisfies regulators. Because in financial services, multi-region isn't optional, it's mandatory. And the requirements are specific. See you in episode 13.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.